If your boat is running one of about 9 specific engines, the smartest money you'll spend this season is the money you spend getting out from under it. And over the next half hour, I'm going to name every one of them, tell you what each actually costs to keep alive right now in 2026, and hand you a way to check your own before you write another check. Some of these are genuinely bad engines. Some are good engines in an impossible situation, which is worse, because a bad engine at least warns you. And the thing that kills a boat engine is almost never the engine. It's what's standing behind it. The parts pipeline, the dealer network, the one casting nobody can inspect, the company that decided on a Wednesday afternoon that your motor was no longer part of the plan. I've had enough powerheads on the bench and pulled enough exhaust elbows off small blocks that I can usually tell what I'm looking at by the weight of the casting in my hands before I ever look inside it. That's not a credential, it's just hours. But it's the reason I know that the scariest engines in this business don't sound bad at the dock. 3 things to hang on to while we go. Number 5 is an engine sold as the most reliable 4-stroke on the water, and it rots from the inside of a part a garden hose has never once touched. The bill usually shows up somewhere between 500 and 700 hours, which for most of us is year 8 or 9, which is exactly 1 year after anybody has to help you. Number 7 isn't a brand at all. It's a cast iron part that costs a couple $100, and it has drowned more marine engines than every manufacturing defect on this list combined. And number 8 is an engine that beat the 4 strokes on fuel burn, won awards, had a fanatical following, and was killed by a spreadsheet in May of 2020 with no warning to anybody who'd bought one the week before. Let's start at the bottom, because the bottom is easy, and then it gets uncomfortable. Here's the frame for the whole list, and it's the only thing you really need. There are 2 kinds of engines in the world: engines built to be rebuilt, and engines built to be replaced. The old iron was built to be rebuilt. Oversized pistons on the shelf, a block you could bore, a shop manual that assumed you'd be inside it someday. The modern stuff is largely built to be replaced, and everything downstream of that decision, the parts pricing, the diagnostic access, the way a dealer talks to you, flows from it. Every engine on this list is either an engine built to be rebuilt that nobody makes parts for anymore, or an engine built to be replaced that has quietly reached the replacing stage. Number 1. The budget 2-stroke outboards from the Chrysler and Force era. Brunswick discontinued Force in 1999, and the reasoning was straightforward. The EPA was tightening the screws on 2-stroke emissions, and nobody was going to spend real money modernizing a platform that was already old. So the youngest one out there is now pushing 30, and the oldest are approaching 40. Some parts are fine. The pieces that were Mercury-derived can still be had, and the ignition and cooling stuff gets reproduced by the aftermarket. It's the older Chrysler architecture parts that put you on eBay at 11 at night. Here's the specific trap. Force built up to 15 variants per horsepower per year, so a carburetor kit that fits your neighbor's motor may not fit yours, and you won't find out until the box arrives. If you're mechanically inclined and it's a duck boat, keep it running and enjoy it. If it's your only motor and you fish 30 miles out, no. That one's mostly about age. The next one is about something an owner did on purpose and hid. Number 2. The 3-liter 4-cylinder. The GM 181 block, sold under both the MerCruiser and Volvo Penta badges for decades. I want to be fair because plenty of good people are going to argue with me. That little engine is arguably the most installed marine engine in history, and by reputation, it's about as bomb-proof as a runabout motor gets. I don't disagree, but it's raw water cooled in most installations, which means lake or ocean water goes straight through the block, and if it doesn't get drained properly before a hard freeze, it cracks. That's not a design flaw. That's physics. The problem is what happens next. A cracked 3-liter block is cheap to patch badly. You'll find them welded. You'll find them filled with liquid metal and painted over. It holds water for a season or two, and then it doesn't, and by then, the boat is yours. Add a known tendency toward head gaskets, water in the oil, a compression reading that doesn't match its neighbors, and you've got an engine where the condition matters 10 times more than the model. Get the boat on a trailer, get underneath, and look at the freeze plug areas and the lower flanks of the block with a flashlight and a rag. Fresh paint in one small area on a 30-year-old engine is a sentence, not a color. That one's about somebody hiding a repair. The next two are about companies discovering, in public, that a brand new technology didn't work. Number 3. The early Mercury OptiMax, roughly the 2000 through 2002 model years, particularly the 200 and 225. Direct-injected two-strokes were the industry's answer to the emissions rules, and Mercury got there, eventually. But the early ones earned a nickname in the baseboat world that I'll leave alone, and the failure pattern was consistent enough that you still hear it repeated 25 years later. Powerheads coming apart at very low hours, not high hours, 120, 70, numbers like that, with the owner still on his first prop. The commonly repeated explanation is that 2001 in particular went bad because of a change in injector supplier, and I'll flag that as shop floor consensus rather than anything Mercury ever put in writing. I've never seen a document confirming it, and I'm not going to pretend I have. What I do know is that a lot of those motors got new power heads under warranty, and a motor wearing its second power head from 23 years ago is not the same purchase as a motor wearing its first. If you're looking at one, get the serial number and have a Mercury dealer pull the warranty history. It takes them 5 minutes, and it tells you the whole life story. Mercury had the money to eat those warranty claims. The next company didn't, and it cost them everything. Number 4. The Ficht direct injection Johnson and Evinrude outboards from 1997 through the OMC bankruptcy. This engine didn't just fail. It took a 100-year-old American manufacturer down with it. Ficht was a German direct injection design OMC bought and rushed into production, and the first year, 1998, is the one people who worked on them will tell you was the worst. Powerheads let go. Electronic modules cooked themselves. Dealers got so tired of the warranty work that some of them simply stopped taking the motors in. Then, in the weeks before OMC filed for bankruptcy protection in December of 2000, the company issued a service bulletin telling dealers that the 1999 and 2000 200 and 225 horsepower Ficht Ram engines could leak fuel and, in the language everybody remembers, catch fire or explode. Bombardier bought the outboard assets out of the bankruptcy auction and, without any legal obligation to do it, absorbed the cost of finishing that recall and honored the old warranties. Credit where it's due. Here's the part that matters for you today. The fix worked. A Ficht with all the updates performed is not a grenade. The bolts that hold the injectors to the head tell you the story. The small original hardware means it was never done. The larger updated hardware means it was. So this isn't a motor to run from on site. It's a motor where you have to verify a 25-year-old service action was completed on that specific engine. And if you can't verify it, price it as if it wasn't. And even done right, You're running a discontinued injection system on an orphaned platform. The parts you'll want are the electronics, and the electronics are the ones that aren't there. Pause on the counting because a pattern has shown up, and I want to name it. Every engine so far has been sick for a different reason. One is just old, one got patched by a previous owner, two were rushed to market. But look at what actually determines whether you're in trouble. Not the failure, the follow-up. Mercury swallowed the OptiMax powerheads because Brunswick had the balance sheet. Bombardier honored a recall on engines it didn't build. OMC ceased to exist. Same class of problem. Three completely different outcomes for the person holding the throttle. From here on, the engines get better and the situations get worse because the next four aren't about defects at all. They're about what happens when a perfectly sound machine ends up with nobody behind it. That includes the corrosion story I promised you, which is next, and it's the one that changed how I look at any four-stroke outboard over 15 years old. Number 5. The first-generation Yamaha F-series four-strokes, and the 225 in particular, roughly the 2000 to 2004 model years. This is the motor that built the modern four-stroke reputation. Quiet, clean, absurdly reliable in the ways people notice. And there is a casting inside the midsection, the dry exhaust passage, the exhaust guide, the tuner, depending on who you're talking to, where hot exhaust gas passes through coated aluminum. On these motors, the coating fails, the aluminum goes, and the corrosion eats outward into the exhaust housing and sometimes into the oil pan, which lives in the same neighborhood. Here's what makes it vicious. It happens on the inside. A New Jersey Marine surveyor told the Boat U.S. Consumer Protection Bureau back in 2012 that he'd personally seen the damage on 6 engines and knew of at least a dozen more in his area alone, and that the failure isn't outwardly visible. The motor may just lose a little power and start to smoke. You cannot see it. You cannot hear it early. Your annual service does not touch it. And the reported window where it surfaces is roughly 500 to 700 hours. Do that arithmetic on yourself. A recreational boater puts on well under 100 hours a year. Most people I know are closer to 40. So 500 to 700 hours is year 8, year 12, year 15. Long past any warranty, past the extended coverage, past the point where anybody at the counter feels obligated to you. Owners were quoted in excess of $3,000 for the repair. One of the class representatives in the litigation that followed had an invoice a shade over $3,000 on a motor with 650 hours. That was in the record. And it isn't only the old ones. There are owners in those public complaint threads describing 2016 model year 150s needing the exhaust guide, the midsection, and the oil pan replaced at 750 hours on one engine and 850 on the other, waiting on back-ordered parts. I want to be fair. That's an owner complaint, not a documented recall. And Yamaha has sold an enormous number of these motors that have never had the problem at all. The honest picture is that the first-generation big block four-strokes are the ones with the serious documented pattern, and that dry side exhaust corrosion on outboards generally is a real, ongoing, not fully solved thing the industry does not enjoy discussing. What do you do about it? On a first-gen F-series you're buying, you get the midsection opened or you price the motor as though it needs the exhaust work, because sooner or later it does. On one you already own, the tell is a motor that's quietly lost a bit of top end and started smoking a little more than it used to. Don't wave that off as age. Hold on to that one. I'm coming back to what Yamaha's dealers told owners about the cause, because it's the most instructive sentence anybody in this industry has said out loud in 20 years. Number 6. Any boat still running an OMC Cobra or, God help you, a stringer stern drive. OMC went bankrupt in December of 2000, and while Bombardier bought the outboard business and the Evinrude and Johnson names, the sterndrive line became an orphan on the spot. Sterndrive engineering and a handful of aftermarket outfits still cover a lot of the wear items today, so this isn't a total desert. But 2 things bite. First, the Cobra shift system, including the electric shift assist, needs precise adjustment and specialized tools. And the honest reality in 2026 is that finding a technician who is both willing and competent is a genuine problem in most markets. Second, that shift system is the actual killer. Cobras have a reputation for eating their gear sets, and the usual root cause is a failed or maladjusted shift cable letting the clutch dogs chatter. The drive doesn't die from age. It dies from a $20 cable nobody replaced on schedule. That's the tell for the whole category. Before you buy an orphaned drive, call the 2 nearest marine shops and ask one question: will you work on it? If they both hesitate, you're not buying a boat. You're buying a project with a hull attached. 3 more to go, and the biggest one is next. Quick thing while we're at the halfway mark. If you're getting something out of this, subscribing keeps these coming and costs you nothing. That's the whole pitch. Because number 7 isn't an engine brand at all. It's a $250 cast iron part on a perfectly healthy V6 or V8. And it is the single most common way a good marine engine dies in this country. Number 7. Any raw water-cooled gasoline stern drive or inboard still wearing its original exhaust manifolds and risers. Stay with me, because it's the least glamorous item on the list, and it will save you the most money. Here's the mechanism. Your engine is a truck engine. A truck engine's exhaust manifolds just get hot and glow. A marine engine's manifolds are hollow. Cooling water runs through jackets cast right into them, and then at the riser, the elbow on top, that water gets dumped into the exhaust stream to cool it and quiet it. So you've got a cast iron part with hot gas on one side of a wall and salt water on the other side of the same wall, forever. Those parts are not permanent. They are sacrificial, exactly like your anodes, just on a longer clock. The old hands will tell you to think of them as very slow zincs, and that is the best way I've heard it put. When the wall finally goes through, water crosses over into the exhaust side, runs downhill into an open exhaust valve, and sits in a cylinder. If you're lucky, you get a rough start and rusty water on a plug. If you're not, the engine hydrolocks on the next crank and bends a rod. And now you're not buying a $200 elbow, you're buying a long block. Intervals. Sources disagree, and they disagree hard, so I'll take the conservative number. Some very experienced saltwater guys will tell you they've smashed apart 10-year-old manifolds that looked fine inside, and I believe them. The published guidance runs closer to 4 to 5 years on risers and salt, and 6 to 8 on manifolds, with hard saltwater use pulling that down toward 3. Freshwater doubles or triples all of it. My rule, and it's a rule and not a fact. In salt, pull the elbows at year 5 and look. There is no way to inspect them from the outside. None. Anybody who tells you they tapped it with a screwdriver and it's fine is guessing. Now the safety part, and this is not optional. An exhaust leak on a boat isn't a noise problem. Carbon monoxide is the leading cause of poisoning death in this country, and it carries straight over into boating. The Coast Guard has documented boating CO fatalities for decades, and the agencies involved openly say the real number is higher than the recorded one, because the symptoms get written off as seasickness or flu, and because people who go into the water unconscious get recorded as drownings. Exhaust leaks are the leading cause of CO deaths on boats. The Coast Guard's own guidance is about as blunt as guidance gets. If you can smell exhaust, carbon monoxide is present. So put a marine-rated CO alarm in any enclosed cabin and treat a rusty streak or a soot mark at an exhaust joint as an emergency, not a to-do. If you keep the boat, the real fix is a closed cooling conversion, antifreeze in the engine and the manifolds, raw water only in the heat exchanger. It costs real money up front, and it changes the arithmetic of owning an older gas boat in salt completely. That's an engine you can save. The next one you can't, and it never did anything wrong. Number 8. The Evinrude E-TEC and E-TEC G2. On the 27th of May, 2020, BRP announced it was discontinuing production of both immediately and repurposing the Sturtevant, Wisconsin plant. The stated reason was the pandemic's impact on the outboard business, with the CEO's language being that the segment had already been facing challenges and the moment had forced their hand. Something like 650 jobs went away worldwide. And here's what makes this the saddest entry on the list. The engine was good. The G2 in particular outran a lot of 4 strokes on fuel economy and torque. It required almost no dealer maintenance for years at a stretch, and the people who own them are, to this day, some of the most loyal owners in boating. They are going to disagree with me for putting it here, and I want them in the comments, because they've got a point. But the point I have is about the 10 years after. BRP committed to supporting owners, warranties honored, service parts supplied. And the figure that gets repeated across the industry is part support for about a decade, putting the official window somewhere around 2030. Take that at face value. I've never seen the underlying commitment document myself, only the reporting on it. What I can tell you from the customer side is what support means in practice. It means orders get filled when they can be filled. It doesn't mean every part number is sitting on a shelf. Impellers, thermostats, injectors, for the common models, are still moving. Model-specific electronics are a different conversation. So the E-TEC isn't on this list because it's bad. It's here because if you're planning to still be running that boat in 2032, the clock on the parts is louder than the clock on the engine, and the moment to trade out of an orphan is while everybody still remembers it was good. Second pause. Notice what's changed. The first 4 engines were about defects. These last 3 are about abandonment. The drive nobody will service, the outboard whose factory closed, and now the last one, which is about an engine designed from the start never to be opened at all. Then I'm coming back to Yamaha's dealers, and what they told owners was causing the corrosion, because that single explanation is the whole game in one sentence. Number 9. The small automotive-derived marine diesels that cannot be economically rebuilt, mainly the Cummins MerCruiser diesel QSD engines and the Volvo Penta D3. I'll be upfront that I've spent more of my life inside gasoline engines than small marine diesels, so weigh this accordingly and argue with me if you know better. But the argument goes like this. A traditional marine diesel is a heavy industrial lump designed on the assumption that in 20 years, somebody will pull it, bore it, drop in oversized pistons, and run it another 20. That's why old diesels are worth money. Modern light-duty automotive-derived diesels use parent bore blocks, which gives you a beautifully accurate cylinder with excellent heat transfer. And by design, no meaningful material left for a rebore. There often are no oversized piston kits, because there's no oversize to go to. Owners in the diesel forums have reported being told directly by Volvo that those engines are not rebuildable. I can't verify that as an official corporate position, and I won't state it as one, but the parts catalogs behave exactly as if it were true. Layer on the orphan problem. Cummins and Mercury ended their marine diesel joint venture years ago, and the QSD sterndrive engines from that partnership are now supported by specialist suppliers rather than by a company with a stake in your boat. And the D3 is at heart a 5-cylinder that came out of the automotive world at a time when the automotive world was walking away from diesel entirely. There are owners who have had a D3 die and genuinely struggled to source a replacement in the United States and in Sweden. So the specific failure mode isn't a broken part. It's a repair estimate that lands somewhere north of the value of the entire boat, delivered to you by a shop that's genuinely trying to help. Now, back to Yamaha and the sentence. When those first-generation 4-strokes started rotting from the inside, some owners took them to their dealers and were told the corrosion was their own fault, that they'd failed to flush the engine after every use. Sit with that, because it's a masterpiece. It's plausible. It's the sort of thing that makes a boat owner feel guilty immediately, because there is not one of us who has flushed the motor every single time without exception. And it puts the whole matter to bed with no cost to anybody but you. It is also, as far as I can tell, physically impossible. The part that corrodes is a dry exhaust passage buried inside the midsection. That's the point of a dry exhaust. Cooling water doesn't go through there. Flushing pushes fresh water through the cooling circuit. It has no route to the casting that's failing. You could have flushed that motor with distilled water after every single trip of your life, and the same casting would have rotted on the same schedule. The surveyor who looked at these for boat use said as much, and the owners in those threads said it more bluntly. How exactly do you maintain a portion of the exhaust buried inside the midsection? So, what were you actually offered? A parts kit, around $600 or $700 in parts for the kit itself, on a job where the labor is a teardown and the total lands in the thousands. And that's if your motor's out of warranty, which it always was, because the failure was documented as showing up at 500 to 700 hours, and you don't put 500 hours on a boat in 3 years. The litigation went nowhere for the owners. Claims got dismissed on the legal machinery, privity, timeliness, jurisdiction, insufficient evidence that the manufacturer knew before it sold, and an appeals court affirmed the jurisdictional piece in 2017. I want to be precise, because precision is the whole point. No court found those motors were fine. A court found that these particular plaintiffs hadn't cleared these particular legal hurdles. Those are entirely different sentences, and only one of them helps you. The one detail the district judge did acknowledge is that the company had moved to a different design and different materials for the second generation. She also noted, reasonably, that companies redesign things all the time, and that alone doesn't prove they knew. Fine. Take that at face value. Here's what you're left with regardless. They changed the design. They did not tell the people holding the old one. And the remedy on offer was an invoice. That's the move. And once you've seen it, you'll see it everywhere. Not a lie exactly. A cost story that costs the company nothing, that lands the blame on your habits, that arrives from someone in a branded shirt who sounds like they're on your side, and that gets between you and the question you should be asking, which is never did I flush it enough. It's can water reach that part at all? You know the sentence now. It will not work on you twice. Here's the thing underneath all of this. And it isn't really about boats. Being able to look at a machine and read what it's going to cost you is a skill, not a personality trait, not luck, not something you're born with. A skill, like reading weather or reading a chart. And it's the one skill the entire consumer economy is arranged to prevent you from developing, because a person who can look at a 20-year-old sterndrive and see the exhaust bill coming in 3 years is a person who is very hard to sell anything to. The old-timers around any boatyard have it. It's why they seem cynical when you first meet them and why they turn out to be right. They aren't smarter than you. They've just watched enough boats die to know that machines don't fail randomly. They fail in patterns, on schedules, in the places where somebody's cost calculation and your ownership intersect. Every one of them learned it the expensive way, one repair bill at a time, and then gave it away free to anybody who'd stand there and listen. That's the part I like. It's a body of knowledge with no owner and no price on it, held by people who have nothing to gain by telling you. So, here's your procedure. Not a rule of thumb. Something you can run on your own boat, with your own numbers this week. Step 1. Get the exact model and serial number off the plate. Not it's a 250, the serial. Everything downstream depends on it. Step 2. Price 2 numbers for that specific engine, a complete exhaust job, manifolds and risers and gaskets, and a replacement powerhead or long block. You can get both in an afternoon from an online marine parts catalog. Write them down. Step 3. Test the parts pipeline. Pick 3 ordinary wear items and 2 failure items, impeller, thermostat, plugs, then an ignition module and a lower unit component, and try to actually buy them today. Note what's in stock and what has a lead time. Lead time is the real answer. Step 4. Call the 2 closest marine shops. 1 question: will you work on this engine? Silence is information. Step 5. Get the physical facts. Compression on every cylinder and a leak down if the numbers wander. On a gas stern drive in salt, pull 1 exhaust elbow and look inside. On a first-gen 4-stroke outboard, get the midsection opened or price it as though it needs the work. Now the decision. Add your likely spend over the next 3 years to what you'd pay today for the boat. Compare that to 2 things. What an installed repower costs, and quote, installed, never engine only. Because rigging is where estimates blow up. And what the same boat with healthy power is actually selling for. If your keep it number lands above the market price of the equivalent good boat, you have your answer, and it's the answer you didn't want. And here's what winning looks like. Not a moment on the water. It's a phone call you never get. It's the 3rd week of July. Everybody at your ramp is having a season, and somewhere across the parking lot, a guy is standing next to an open engine hatch with a shop estimate in his hand doing math he doesn't like. And you're not in that conversation. You already had it 2 years ago at your kitchen table with a parts catalog open, and it cost you an afternoon instead of $11,000. That bill never arrives. You'll never even know exactly how much you saved. That's how you know it worked. Now, the comments. I don't want the wins. I want the confession. What's the engine you bought anyway? The one where somebody warned you, or you had the funny feeling and talked yourself past it. And what did it cost you in the end? Put the number in. The number is the useful part, and somebody reading this on their phone in a driveway right now is about to make the exact same call you did. And if you're in the Gulf or the Pacific Northwest or a freshwater lake that freezes hard every winter, say so, because the same engine lives 3 completely different lives depending on which of those you're in. I read them, all of them, eventually, usually later than I should. If you want more of this, subscribing is the whole ask. And there's a thread I deliberately left alone in here, which is hours. Everybody buys and sells these engines on the hour meter, and I have been trying for a long time to get a straight answer out of anybody about how many hours the exhaust side of a modern 4-stroke outboard actually has in it before it needs opening up. Nobody will say. The manufacturers won't publish it, the dealers hedge, and the surveyors give me a range wide enough to drive a truck through. I'm still working on it. Until then, pull the elbow, buy the serial number, and don't ever let a man in a branded shirt tell you it's because you didn't flush it.